The power handling capacity of a 1:1 current balun on a toroid is primarily determined by its ability to manage heat dissipation and avoid magnetic core saturation. The important factors can be discussed under core properties, winding properties, and application conditions. Different mixes like mix 43, 61, etc. are optimal for specific frequency ranges. Using the wrong mix for the operating frequency leads to increased core losses and heat generation, which limits power. A large core or stacking multiple cores provides a greater area to dissipate heat and handle higher magnetic flux without saturating. For example, stacking two FT240 cores can roughly double the power rating compared to a single one. FT240 core has an outer diameter of 2.4 inches. The inherent properties of the core material determine how much energy is lost as heat due to hysteresis and eddy currents at a given frequency and flux density. The maximum saturation flux density of the core material is a critical limit. If the power level or low frequency operation causes the core to saturate, its performance is compromised and it will heat up rapidly. Using high quality, high temperature insulation like PTFE, polytetrafluoroethylene, is essential to prevent the wire insulation from melting or breaking down under heat. PTFE insulated wire or coax is preferred for high power applications. The wire must be thick enough to handle the current without overheating from its DC and AC resistance. For best results, a 1:1 current balun should be wound with a transmission line, bifilar wire or coax that has a characteristic impedance close to the system impedance. Example, 50 ohms for a 50 ohm system. The balun's power handling is frequency dependent. A balun designed for HF may not work well at lower or much higher frequencies due to changing core properties like self-resonance or insufficient choking impedance. Continuous operation modes like FT8 or RTTY generate much more continuous heat than intermittent modes like SSB, requiring a higher power rating or significant derating. While common mode current, which is blocked by the balun, is the primary factor causing core flux, a high standing wave ratio SWR on the feed line can cause more power to be dissipated as heat in the balun due to increased common mode currents, especially if the antenna is not a good match for the feed line.